Hello, welcome to Learn at JOES. Today we will be looking at the NUCLEO-L152RE development board. This development board features the STM32 L152RE microcontroller with, as it says here, 512K bytes of flash. It runs at 32 megahertz. It's got USB, and among its set of mixed signal, it's got a couple op amps. Here's the circuit diagram of the micro. Here's a copy of the development board on the bench. I've already wired two LEDs to the Arduino header interface of this board. Within the STM32 Cube IDE and the Cube MX configuration utility, I've added my my two LEDs. I just call them LED 2 on PA10 and LED 1 on, looks like, PB5. And I picked those because within the user manual for the NUCLEO board, the pin D2 or D4 or by reference with the micro, PB5 and PA10 by default do not have any other functions assigned to it, so reduce the risk of any conflicts of assignments. Now, DigiKey has a tutorial page to introduce the FreeRTOS and how to get quickly started with FreeRTOS on the STM32 platform. They put a nice intro onto what is an RTOS, or real-time operating system, and why you might want to use one. Of course, you can go to their FreeRTOS website, and they have a quick start guide. But you follow the instructions through the Cube IDE is a much simpler, more straightforward experience. So I'll go ahead and set that up here. I'm just going to go into the middleware section as prescribed here. And we're going to enable the FreeRTOS middleware. And we're going to use the SimSys V2. Then we got my configuration panel down here. I'll go ahead and follow the guide here from the webpage, which I will link in the description below for this video. Go ahead and add a couple of tasks here. Or I'll edit the first task that's here and then add the next one. At this point, I will go ahead and update the HAL timer to use the timer 6 instead of the SysTick that we want to use for the FreeRTOS. And we'll go ahead and save and regenerate the code. Very well, the code, including this main.c, has been updated to add our tasks and to add our tasks to initialize. We have our handles for our task functions, and we got some OS inits, start the task, and have the kernel run. Here within the source is the two tasks that I have created, or at least the stub functions. And I'll go ahead and add some action to toggle the LEDs within these tasks. And we'll toggle the LED 1, which I think is the red one on my board, every 500 milliseconds. Or we'll toggle it, and then the task will go to sleep for 500 milliseconds until it gets reawakened again. I'll make task 2 LED run at 500, and task 1, since it's running a little fast, it's running at higher priority, I'll have them go at 250. Not that it makes too much of a difference. Go ahead and build, and we will debug it. And we'll hit resume. And we can see that the tasks are toggling our LEDs on the board that I've put here. Heading back over to the configuration utility. The setup for this project, for this Nucleo board, includes the blue push button D1 that's tied to PC13, and it is configured for external interrupt mode. On the Nucleo board, it's the button with the blue hat. If I tab over to the NVIC, or the nested vector interrupt controller, it does have a toggle to enable the X1 line interrupts. Go ahead and set that and save. Alright, looking within the interrupt handler file, the generator did add a handler for us for the X15 IRQ handler, and it's got a function here that gets called. And it goes to a callback function. Alright, I've gone ahead and added a callback function to my main C file. Right now it doesn't do anything, but I did add a breakpoint to it to see if we can hit it when I press the button on the board. Go ahead and build, which I think I just did. Now I'll go ahead and press that button. And I did hit the breakpoint within my main C function for the callback. Now, one idea that we could do is have the red LED that's controlled by task 2 toggle upon pressing of the button. Now, without an RTOS, one way of doing it would be to set a toggle LED variable, and then when we get the interrupt, just set it. Oops. And then within the task, say if the LEDs, if the value is set, do the toggle, and then clear the flag. And we see on the bench, if I press the button, the red LED toggles by the task number 2, and when I press it, he turns off again. Now, of course, this is not an optimal way of performing this response operation, because this task has to be waken up just to find out that there is nothing to do and go back idle for another 500 milliseconds before it wakes back up. A better way of leveraging the RTOS environment is a use of a semaphore that could be posted by the callback function and gets pended and receives the semaphore by the task. Going back into the FreeRTOS configuration, there is a setting or a tab for timers and semaphores, and I'll just add a binary semaphore right here, and we'll just call it the button press semaphore. And we see that the semaphore definition has been added to the main file. Navigating the project directory down to the SimSys RTOS v2 interface files, we see that we have a header file for the SimSys OS2, and within the header file we have function declarations related to the semaphore operation, and these functions are provided by the SimSys generic interface. And going into the actual function, they basically are a front end to the FreeRTOS functions that perform these operations for us. Alright, I've gone through and cleaned up the code a bit here. In the callback function that is called under the interrupt context for the button, I have a call to release the semaphore. And within the task 2, it's been updated so that instead of having a delay at the end, we go in and we attempt to acquire the semaphore, and while it's waiting, the other tasks will perform. And when it times out, it'll come back here and check to see if we got it. And if we did, it will toggle the LED. Here we are with our board again. We see that the task 1 is still blinking the blue LED at 250 milliseconds interval. And I'll go ahead and press this button here. There we go. And the red LED has toggled. We press it again. It turns off.